Hello everyone. In this video we're going to be doing LeetCode problem 704, which is binary search. So this problem states, given an array of integers, nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with big O, log of n, runtime complexity. So in example 1, we have -1, 0, 3, 5, 9, and 12, and the target is 9. So index 0, 1, 2, 3, 4. So the output is 4. In example 2, the target is 2, which doesn't exist in nums, and so the output is -1. Do this. So basically the binary search is cutting the array in half and then figuring out if the number you're looking for is in the first half of the array or the second half. And if it's in the first half, you remove the second half. And if it's in the second half, you remove the first half and continue on. So that's exactly how we're going to code it. So we have a midpoint, we have a left, and we have a right, which is the num's length, -1. So we're just going to loop through while the left pointer, so we're going to have 2 pointers, so the left pointer will start at the leftmost position, the right at the rightmost position. And so while the left is less than or equal to right, we're going to define a mid. Now this is basically it's left plus right divided by 2, but this is I guess a better way to write it, code it so the numbers don't get too large or whatnot, if the numbers are larger. So left plus right minus left divided by 2. So if nums mid equals the target, return the mid. Else, if the target is less than nums mid, means that the number is somewhere on the left side of the array, then we're going to take right and move it one place to the right. So we're going to take it, we're going to take it to the midpoint and then subtract 1. So it would be 1 less than the mid. And then otherwise we're going to take the left side and remove it and make it equal to mid plus 1. And that is pretty much the meat behind a binary search. And if we don't find anything, then we return -1. Alright, so let's debug this and see what we get. So I picked the first example. Target is 9. So we're just going to go through this. So left is 0, right is 5. Left is less than or equal to right. So we're going to make the mid point the middle between those two numbers, so it's going to be 2 because it's an integer, so we round down. So if nums at position 2 equals the target, which it does not, else if the target is less than the nums mid, we're going to take right minus mid minus 1, which it isn't. Else the left equals mid plus 1. So left is now going to become 3. So now we have 3 and 5. Right is still 5. So we're going to make the mid equal 4. So if nums at the mid position, so 0, 1, 2, 3, 4, I'm sorry, 0, 1, 2, 3, 4 equals the midpoint, which in this case it does, then we just return that. And that is how you do a binary search. Alright, let's run this through LeetCode. See what we get. Accepted. We'll submit it. Look at that, 100%. Faster than everybody. And uses less memory than about 60%, so that's not too bad. Last thing we'll go through is the time and space complexity. So we had to do this in O log of n, and this standard binary search functionality, this is exactly what it is, log of n. And the space complexity is O of 1. So we pass in array and we pass in the target, and we don't do anything to require more space when we're calculating that. And that is pretty much it. So thanks for watching. Let me know if you have questions, and we will see you next time.